how do we start? Well, a particle is accelerating along a curved path of length L equals 4.0 meters under the action of an applied force, as shown in this figure. The total work done on the particle is going to be the integral from 0 to L, and they're telling us L equals 4, of f of x dx, and this is Newton meters. So we're going to do this for a few different functions, and basically all we're really going to be doing is integrating. For A, we're going to integrate from 0 to 4 to x to the 4th plus 3x to the 3rd plus 4x minus 1. And when we do that, we make sure we put this dx. That dx comes from, remember, we're finding the area of those rectangles. If we just take the y values and don't multiply it by the small width, then we don't have the area, we just have the height. Don't forget, that dx is actually more important than you think. All right, and this is what w equals. The first thing we do is we use the power rule, and the power rule is that the integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. Okay, so we're going to do that for each and every one of these. So, oh, and we're also going to use the fact that the integral of f of x plus g of x dx is equal to the integral of f of x dx plus the integral of g of x dx. Okay, I'm going to integrate each one individually. This is 2 times the integral of x to the 4th, which is x to the 5th over 5. Also, we're using this one. So the integral of c times f of x dx is equal to c times the integral of f of x dx. That just means if I have a constant, I can take it out of the integral sign. So far, these are the formulas that we're going to be using. And if anything else comes up, I'll write it down. And this really is plus or minus. Let me call them 1, 2, and 3. I'm going to do step 2 now as an actual step, which means that I'm going to take this integral from 0 to 4 of 2x to the 4th dx plus the integral of 0 to 4 of 3x cubed dx plus the integral from 0 to 4 of 4x and minus the integral from 0 to 4 of just 1 dx, or you can just write dx. So that's using number 2. I just separated them into separate integrals. I'm going to use 3 and 1 at the same time, just so I don't have too many steps. What I'm going to do is I'm going to take the 2 outside of the integral sign, and then I'm going to integrate x to the 4th, which is using number 1. X to the 4th is going to be x to the n plus 1, which is 5, divided by 5. The integral of this first function, and I'm going to evaluate that between 0 and 4, plus 3 times the integral of x to the 3rd, which is x to the 4th, over 4, again between 0 and 4, plus 4 times the integral of x, which is the same as x to the 1st power, so it would be x squared over 2, also between 0 and 4. And then the last step, minus x because that's really 1 dx. The integral of 1 is x. It's like x to the 0. You can think of this here. You can think of the integral of dx as x to the 0 power. So you would add 1 and divide by 1. So it'd be x to the 1 power. And this is also going to be between 0 and 4. And now basically we just plug in our values. So this is going to be equal to 2 times. And the first thing I do is I plug in 4 for x. I plug in the top number. So I have 4 to the 5th power. Let's do it like this, over 5. And I subtract, I plug in the bottom number. So I have 0 to the 5th power over 5. And then I have plus 3 times 4 to the 4th power over 4 minus 0 to the 4th power over 4. And obviously you don't need these zeros. You don't have to put them in. I'm putting them in just to show you what's happening. And then I have 4 times 4 squared over 2 minus 0 squared over 2. And minus, and I just plug in the 4. I have 4 minus 0. And now we just evaluate, we come up with a number. Okay, this is going to cancel, this is going to cancel, this is going to cancel, this is going to cancel. And you're going to get 2 times 4 to the 5th over 5 plus 3 times 4 to, actually, I'm going to cancel one of these 4s. I'll just say this is 4 cubed plus 4 times, and that's 16 over 2, which is 8 minus 4. And I do have the answer here as 629.6. And this is Newton meters.